Thanks everybody to come to this demo. And for today, I want to talk a little bit more about functional safety. And more importantly, that what is the challenge the industry is facing today and how NDs create solutions to help the industry to solve those challenges. So first, when we look at what happened in the automotive industry today, we find that we're going through a revolution right now, that there are multiple driving forces is changing the landscape of this industry. For example, we're having a lot of EV driving on the street today, so the new energy vehicle is rapidly replacing the gasoline cars. And the car is also getting smarter and smarter every day. So the ADAS system on the car nowadays start to become a major point of differentiation when people come to the dealership to buy a car. Another thing is the software-defined vehicle and drive-by-wire, that it fundamentally changed the concept of the car. So when you build a car, the concept is no longer limited when you design and build a car. But even after you ship the vehicle to the hands of your customer, that the car company still push through the over-the-air update on the firmware and the software to change how the car behaves with the driver. And another change is the V2X, which represents a vehicle to everything. So your car is connected to the world, to a cloud. There are various different applications. For example, that you have GPS and you have emergency road services. But even for the important functions such as the ADAS system, that sometimes you see the ADAS system will require you to go to a cloud and download the high-definition map to the vehicle in order to just keep the car in between lanes. So with all those change and driving forces, we can see a conclusion that in today's automotive industry, that more and more CPU is needed. And with those additional CPU, the functional safety will become more important than ever. So here in this slide, I want to share some of the structure and the common component when we come to the functional safety development. So first, usually when you start a project, you need to define the concept, and there are things that you need to cover is what is the safety requirement for your design, and for the IP, what is the assumption of the use. This defines the scope of your design. For most of the IP developer, that most of the team is choosing to go with the out of context methodologies. That if you're on the user side, if you're the IP integrator, there are some of the important topics that you need to be aware of. So for example, the functional safety evaluation, the ASIL-B or ASIL-D, it's not just that certification, that piece of paper, but you also want to understand the assumption of use, what is the scope of those evaluation. And there are other things you also need to be aware of. For example, how to configure the processor core and how to integrate the safety design for the IP into your system. So those things will help you to support the safety concept that you want to create within your system. And when we come to a safety design, then there are some of the important things that you need to know is, first, it's the safety mechanism. Most of the IP comes with internal and the external safety mechanism. So if you're the IP integrator, you definitely need to know what is the external safety mechanism provided by the IP provider, so you can perform the integration right. And for example, at NDs, that we provide all of our CPU, the functional safety CPU, for an additional core trap status bus interface. So on the system side, you can keep track of the status of the processor. So for example, if the CPU hangs, your system knows that, you can reset the CPU and return your design back to the safe state. And the fault tolerant time interval is also a very important concept. It defines between the first incident happens, first exception happens in your system to when, how long does it take to bring your design back to a safe state. So when you're doing the design, this is also a very important concept. And when it comes to a functional analysis, the safety analysis, this is one of the cornerstones for the functional safety development, because you need to provide the evidence to convince people or the safety auditors to make sure that your design do meet the requirement for various different safety level. I'm showing that table here for the requirement between ASIL-B, C, and D. So this is what I need to do with all those safety analysis in order to provide the evidence that your design do make the requirement for either ASIL-B, C, or D. Yeah, let's take a quick look at some of the application between different safety level. So several of those applications you see here, they are the typically that people would choose to go with the ASIL-B requirement. So this can be from inside your car to outside your cars. Inside your car, you can monitor the driver, have a control for the touching display or the storage. Outside the car, various different ADAS features that you're going to need to protect that and make the safety requirement to be at least ASIL-B. And when it comes to the ASIL-D application, that this is usually more safety critical application. So some of those examples you see here for the power steering system, for example, or the engine management, electronic stability control, or for the EV that you typically have the battery management system and the motor control. And those functions are highly critical for your safety. That's why when it comes to the ASIL-D requirement, that these are typically the application that you can expect. So from here, this slide, I want to show the roadmap for the solution provided by the Andes. And what you can see here, in 2023, this year, that we provide two different designs, the N25 FSE and the D25 FSE. We describe this as the mainstream processing because what happens today in the automotive industry is that people will tend to, the automotive industry still try to ramp up their confidence for the RISC-V design. So most of the opportunity and most of the design you can see is more on the ECU or the smaller controller for a specific subsystem of the car. And we can see that there's a lot of use cases for this type of microcontroller. And for those two processors that we provide the ASIL-D fully compliant certification. And going forward for the next year, what we're looking to is to take a step up and further provide the ASIL-D design. There's going to be two designs that's going to be launched next year. At the first half, that we're going to provide the D45 SE. That this core will be a step up from the 25 series for the performance and for the safety, since this is ASIL-D. And for the second half, the second core we're going to provide next year is the D23 SE. And this core is aiming at the additional power efficiency and as well as the security feature that we add to this core. And right now that we expect this core to pass its certification at Q3 next year. And if you want to look even beyond that, in 2025, Andes will further provide a high-performance core from our AX60 series. And this core is aiming at more of the high-end applications such as ADAS, or you have your infotainment system on your car. This is what this core is designed for. So what you're seeing here is some of the architectural highlight. I want to quickly run through some of the detail for this course. That for the N25 FSE and the D25 FSE, this is a 5-stage in-order single-issue processors. Both of the processors are 32-bit RISC-V architectures. When it comes to the instruction set, we provide the ISA for the GCBP. And one thing to know here is the P extension is for the PAC SIMD, so you can implement your SIMD algorithm on this core. And this is available on the D25F. And for the N25F, that this will the instruction set extension will be just GCBP. And when it comes to memory subsystem, that the user can configure various different levels of the memory, including cache and local memory for your data and the instructions. And the bus interface on those cores support all the common bus interface like HB and ASI. And if you choose to configure the local memory on the core, we also provide an additional slave port that you can share the data with the system. And for the functional safety that I mentioned, the core trap set as bus interface. And beyond that, all the memory on those cores are fully protected through various different mechanisms. The N25 FSE has been certified since November last year. And for the D25 FSE, that this core will become available before the end of the year. So another core I want to introduce is the high performance a more secure core, the D45 SE. This core has some similarity and has some difference in the improvement compared to the 225 series cores that I just talked about. For example, the CPU cores is 8-stage in-order dual-issue architectures. So for that, you can expect there's going to be quite some improvement on the performance side. The ISA support on this core is also similar to the D25 FSE that we just talked about. And for the memory subsystem, one of the important features we add to the D45 is the main boost. The main boost is a technology that we essentially make a series of different improvements for the memory transaction on the core. So in average, that you can expect about 2 to 3 times memory throughput compared to the 25 series. And this will match very well with the additional compute power that we provide in the pipeline. And I want to just talk about the additional feature for the functional safety. Because this core is aiming at ASIL-D application, so typically that in order to reach additional diagnostic coverage and safety standard, we provide the dual-core lockstep on this core. And so for the dual-core lockstep, there's several different ways you can use it. You can either go with the ASIL-B compliant design that you configure 2 cores and have them lockstep with each other, or you can convert these 2 cores in either the split mode, which 2 cores is working separately, or you can configure this with just 1 core and use that as ASIL-B functional safety processors. And we're looking to provide this core to our customer somewhere around the first half of next year. And yeah, that concludes my presentation. And the one thing I want to add is that NDIS provides a very comprehensive product portfolio for different kinds of processors, all the way from efficiency to high performance core for each of the different application scenarios. And if you want to know more details about the NDIS technology and our product, you can go to our booth at D4 for additional information. And thank you for everybody for the time.